Let us study new topic, that is what are valence electrons, what is valency, then what are isotopes as well as nuclear reaction. So here first we will start with valence electrons. Valence electrons means number of electrons which are present in the outermost orbit. For example, again I am starting with the carbon. Carbon, its atomic number is 6, mass number 12. Now here it's a nucleus. Protons number is equal to the atomic number. Neutrons number is the difference between mass number as well as atomic number. So 12 minus 6 is 6. Now first orbit can have maximum 2 electrons. Then 2 already over. Here atomic number 6, protons number 6, electrons number 6. So here I am writing again P is equal to 6, E is equal to 6, and also in this case is equal to 6 by difference between mass number as well as atomic number. Now first orbit can have 2, then second orbit can have maximum in case of carbon, that is 2 already written. Here total 6 is there, 2 already over. Then remaining 4. Now in this case, this is carbon atom, its outermost orbit has 4 electrons. So number of valence electrons of carbon is 4. Valence electron, its meaning number of electrons present in the outermost orbit. So in this case 4 electrons are present in the outermost orbit. So we can say that valence electrons of carbon is equal to 4. So in this case valence electrons equal to 4. Now I am showing you another example, that is oxygen. O, its atomic number is 8, mass number 16. Now here first orbit can, now this is diagrammatic representation. Now without a diagram also we can be able to write the electronic configuration. So here in this case P, this is the atomic number 8, then protons number 8, electrons number also 8, neutrons number we need to find out, difference between mass number as well as atomic number. So 16 minus 8, that is equal to again 8. Now first orbit can have 2 electrons, 2 already over. From this 8 2 already removed. Now remaining 6 is there. So we can say that first orbit we can make 2 electrons, second then 6 will be there. So we can say that valence electrons or number of valence electrons of oxygen is equal to 6. Its meaning outermost orbit has 6 electrons are there. So outermost orbit has how many electrons? That is known as valence electrons. Now we people are studying about what is valency. Now for finding valency, you have to see that here now outermost orbit has 4 electrons. Here outermost orbit has 6 electrons. So for completing its octet means for completing its 8 electrons, how many electrons more it required, that we have to find out. So here now total 4 electrons are there. 4 plus 4 will be 8. So we can say that how many more electrons are required to complete its octet. Either by adding or either by gaining electrons or by losing electrons. 2 ways are there. So here now outermost orbit has 4 electrons are there. So removing 4 electrons or getting 4 electrons, both of them are very difficult to carbon. So it cannot be able to take 4 electrons or it cannot be able to give 4 electrons. It just does a sharing electrons with some other atoms of the elements. So here now outermost orbit of carbon has 4 electrons, so valence electrons are 4. Even its valency is 4. Either it has to lose 4 electrons or it has to gain 4 electrons to complete its octet condition. So if it is losing 4 electrons, then it will have duplet condition. Duplet means 2 electrons condition. We can say that only the first orbit will be there. That atom has duplet condition. Now more than one atom is there, more than one orbit is there. Those all elements are having, or those all atoms are having octet condition if they are gaining electrons from other atoms. So here now duplet condition as well as octet condition. Here outermost orbit, that means only one orbit, okay. The first orbit only having, or first orbit only can have duplet condition. That means it will have 2 electrons, then we can say that. So if an atom has only one orbit that has 2 electrons, then we can say that that is the duplet condition. Now octet condition means the outermost of the orbit have 8 electrons, then we can say that that is octet condition. So all atoms are ready to work for becoming either duplet condition or becoming octet condition. So here now this carbon has 4 electrons, then it is ready to gain 4 electrons or it is ready to remove 4 electrons. But here means that 4 removal, 4 gaining, both of them are very difficult. So because of that, this carbon is doing sharing work of electrons from other atoms. Now here, in case of oxygen, its outermost orbit has 6 electrons are there. If it receives 2 more electrons from any other atom, it can become its octet condition. So we can say that it can take, now 2, 6 condition is there. First orbit has 2 electrons, second orbit has 6 electrons, then it can receive 2 electrons easily, then remove 6. Now you see here 2, 6 is there. Removing 6 is very difficult, but at the same time gaining 2 is very easy. So which will be easy? That each and every atom is going to do. In case of oxygen, it will receive 2 electrons from any other atom. So we can say that valency of oxygen is equal to 2. Removal of 6 is very difficult, it cannot do. So it will do one work, that means it will receive 2 to complete its 8 condition, 8 electron condition in the outermost orbit. So we can say that that is the octet condition. So we can say that valency of oxygen is 2. Now when we study about lithium, its atomic number is 3, mass number 7. So I am writing here protons number is 3, atomic number, protons number same, electrons number and protons number same. Now we have to find out the neutrons number. Neutrons number is the difference between mass number as well as atomic number. So I am finding now 7 minus 3, that is equal to 4. Now electronic configuration we have to write. First orbit can have 2. Here total 3 is there. First orbit has 2. Second orbit has 10. 1 is there. So electronic configuration of lithium is 2, 1. Now in this case, what will be its valency? Now valence electrons also we can write here. Valence electrons means outermost orbit has how many electrons? So here outermost orbit has 1 electron. So we can say that valence electron is equal to 1. Now we are finding the valency. Now in the case of lithium, outermost orbit has 1 electron. So it can do 2 works. Either it can receive 2, 1 is there now. Either it can receive 7 electrons from any other atoms, or it can remove its outermost electron. Either it can gain or receive 7 electrons for completing its octet. Why? Because second orbit can have maximum 8 electrons, even outermost orbit can have maximum 8 electrons. But here in the second condition, here 2, 1 is there. If it remove this outermost electron, that is 1, if it is removed, then it will have the duplet condition. It will have only one orbit. That orbit can have maximum 2, that will be with it. So which will be easy to this lithium? Either receiving 7 electrons or losing 1 electron. So here in case of lithium, removal of 1 electron will be very easy. So here gaining of 7 electron is not easy. Removal of 1 electron is easy. So we can say that the valency of lithium is equal to 1, because this electron it will give to any other atom. As a result of it, this 1 electron will go away. Then the first orbit only will be there. The first orbit will have 2 electrons. First orbit can have maximum 2. That will be with this. If it will lose 1 electron from it, then we cannot call it as lithium atom. We will call it as lithium ion. Lithium ion. If oxygen, here 2, 6 is their electronic configuration. If it receives 2 electrons, then its valency will be 2. Once it receives 2 electrons from any other atom, we will call it as oxygen ion. So here same way, in case of carbon, carbon cannot be able to give, carbon cannot be able to take, only to just share. So here now, if they lose electron or if they gain electron, how many they are gaining, how many they are losing, that we have to see. So accordingly we can be able to write, in case of oxygen its valency is 2, in case of lithium its valency is 1. Then here just sharing is taking place, so valency of carbon is 4. Now here we are going to study about what are isotopes. Isotopes are the atoms of the elements. Now what is their speciality? Some of the atoms of the elements, or what we can say, some of the elements. Now for example I am showing you gold element, element gold, element iron, even element copper I am showing you here. So these are elements. Speciality what is there? Inside, now one wire I am making with them. Copper wire, iron wire, gold wire. Inside of them there will be number of atoms. Inside a number of atoms will be there. Here their speciality, all atoms will be alike. We can say that in an atom, now gold is there, gold wire, in that how much atoms are there? All atoms are alike. Alike means the same. In case of iron, how much atoms are there? They all are alike. Alike means same. Look wise they will be same. Now copper will be there, then copper, all atoms will be alike. Same will be there. But some of the elements in the nature, their atoms won't be alike. Some variation we can be able to find out. Which variation will be there? Their mass number will be different, but atomic number will be same. Here now few examples I shown. That means all these wires made with the help of atoms. Now here I said that most of the elements, their atoms will be alike. Now in case of gold, all atoms will be alike. Iron, all atoms will be alike. Now copper, all atoms will be alike. Like that way, if we consider some other elements in the nature itself, this is now example like I shown, but there are few elements we can see. Their speciality, those elements are having different types of atoms. Now few examples I am showing you. Here now alike condition will be there, all atoms will be alike, but some cases what is there, all atoms won't be alike. Now here I am showing the example of hydrogen, then chlorine, then carbon. There are few more elements are having isotopes. Here we are studying now isotopes. Isotope means what? Here in the nature, some elements are having different types of atoms which has different atomic mass number but same atomic number. So here now hydrogen has, now we can say that here it's a atomic number 1, mass number 1. Other type of hydrogen has atomic number 1, mass number 2. Other type of hydrogen has atomic number 1, mass number 3. In case of chlorine, if you are seeing, chlorine's symbol is Cn, atomic number 17, mass number 35. Now in case of other chlorine, atomic number 17, mass number 37. In case of carbon, atomic number is 6, mass number 12. Other carbon atom has atomic number 6, mass number 13. Other carbon atom has atomic number 6, mass number 14. So here now, if we are studying about this hydrogen, here you can find that atomic number is same. Here we can say that atomic number same. Here all atomic number same, but their mass number is different. Here mass number is different. Here mass number is different. So we are calling them as isotopes. Isotopes. Isotopes speciality in the nature itself. That means nobody made it. It is present in the nature. Some of the elements are having different types of atoms. Their mass number different but atomic number same. Now here isotopes of carbon C612, C613, C614. Isotope of chlorine Cl17, 35, Cl17, 37. Now here hydrogen H11, H12, H13. Now here one more speciality. In all these cases if we see, atomic number same is there. Because of that we can say that atomic number is the fundamental property of an atom. Because mass number varies, atomic number remains the same. Mass number varies, atomic number same. Mass number changes, atomic number same. Because of that we can say that when we think of an atom, its atomic number is its main, or atomic number shows the main property of an atom. Fundamental property means important property, main property of an atom. Now we will study the uses of isotopes. There are different types of isotopes. Now isotopes of radioactive elements we are using for various uses, like we can say that for agricultural purposes, for industries, food preservation work, then even for research, etc. So let us see now that. Here we can say that the first one, uranium 235. Second, radioactive isotope you have to study, that is Cobalt 60. Third radioisotope which you have to study, that means that these all isotopes uses you are going to study. Next one, iodine 131. Then sodium 24. Then carbon 14. Now here we are going to study about first one, the uses of radioactive isotope uranium 235. This uranium 235 we can use for nuclear fission. This we are going to study in detail, and for electricity production. So here now uranium 235 is a radioactive isotope which is useful for nuclear fission as well as production of electricity. Next one, cobalt 60. Cobalt 60. It is useful for treating cancer. So we can say that this is using for treating cancer. Now iodine 131. This is again a radioactive isotope. This is useful for curing or treating goiter. A disease it is. Goiter, it is a disease of thyroid gland. Thyroid word you might be heard. Thyroid glands a disease, that is goiter. We can say that you might be seen someone's neck is in ball, like here swollen condition you might be seen. So that disease is known as goiter. So we can say that a disease of thyroid gland. Thyroid gland. Now here sodium 24. Sodium 24 again we can say that it is a radioactive isotope which is useful for finding any cracks are getting to the underground pipes. So we can write here for detecting or for finding the cracks, whether cracks are there to the underground pipes, whether there is any crack is there to the underground pipe or not. For finding that we can say that we are using sodium 24. Now here we can see that all pipes are passing through underground only. So whether there is any cracks to them, for finding that we are using sodium 24 radioactive isotope. Now this is carbon 14. Carbon 14 we are using for finding age of the archaeological objects. We can say that for determining or finding the age of archaeological things or objects. Or objects we can say. Archaeological means underground things. Now we can say that if they are finding underground, from underground any skeleton may get, or we can say coal. So many years ago it might be formed. So what is the age of this, or which year it is formed? So for finding such and such things, then we can say natural gas, even we can say that petroleum, such as the crude oil. These are things when it is formed. For finding that, this carbon-14 isotope can be able to utilize. Now we can say that even dinosaur, it's all skeleton. So many other organisms skeleton. After digging under the ground or dig so much kilometers if we are digging and going, from there all means many skeletons are getting. Or we can say some wood or some birds parts. Like that all things are available. Some fish. These are things escaping from decomposition. Some what we can say, they are going in between. They are lying in between two rocks. Such a condition without spoiling, the dead bodies of different organisms are finding from underground. Now their age, for finding that, we are using the isotope carbon-14. Now we will study what is nuclear reactor. Nuclear reactor is a machine which generates electricity by using atomic energy or nuclear energy. Now inside the nuclear reactor, a chain reaction is taking place. How that chain reaction is taking place, that I will show you now. For the production of electricity in the nuclear reactor, a fuel using there. It is a radioactive element, or we can say it is a type of isotope, radioactive isotope. That radioactive isotope is known as uranium-235. Uranium-235. By using this isotope, how they are producing electricity in the nuclear reactor, we will see. First they are bombarding a neutron with uranium-235. Its mass number is 235, atomic number is 92. Now this uranium, so first what they are doing, they are bombarding. Bombarding means hitting a neutron on uranium-235. As uranium-235 is a stable element. Uranium-235 is a stable element. First what they are doing, they are making this stable element as an unstable element. For making it an unstable element, they are allowing a neutron to hit on the uranium-235 atom. As a result of it, this uranium-235 transforms to uranium-236. When uranium-235 forms, along with that, we can say that there will be the formation of 3 neutrons. Then there will be the formation of krypton. Then there will be the formation of barium, and there will be the formation of 200 mega electron volts of energy. Now here its mass number is 92, atomic number here 36, here 141, atomic number is 56. So what is happening here? For the production of, for making uranium-235 to 236, they are allowing neutron to hit on the uranium-235 isotope. As a result of it, it transforms to uranium-236. Along with that, 3 neutrons formation, 1 barium atoms formation, as well as 1 krypton atoms formation is taking place. Again, these neutrons, they are allowing to bombard with again uranium-235. Similarly, here uranium-235, again here uranium-235. Now, as a result of it, this uranium-235 transforms to uranium-236. Along with that, there will be the formation of 3 neutrons, then barium as well as krypton. Along with that, 200 mega electron volts of energy. This energy, how much it is producing? That is a huge amount of energy. It is a heat energy. As a result of it, water boils, which is present inside the boiler. As a result of it, from that steam will come out. That steam help for rotating the turbine. As a result of the machine turbine rotates, there will be the production of electricity in the generator. Now, this process, now I didn't make here full, this process keep on occurring continuously, so we can say that this is a chain reaction. This is a chain reaction. Again and again this process keep on occurring continuously, so it is known as a chain reaction. Chain reaction itself is of 2 types. One is known as controlled chain reaction. Other one is known as uncontrolled chain reaction. Controlled chain reaction is happening inside the nuclear reactor. Uncontrolled chain reaction is taking place inside the atom bomb. Now, if we are not controlling the chain reaction, there may occur very big accident. For avoiding that, inside the nuclear reactor, they are using moderators as well as controllers. Moderators as well as controllers. Now, moderator's duty is controlling the speed of the neutrons which are producing here. Here neutrons are there, here neutron is there. It's a speed one to reduce. For that, they are using which one? Moderators. Now, here moderators are heavy water as well as graphite rods. Their function, they reduce the speed of the neutrons which are producing inside the nuclear reactor. Inside the nuclear reactor, how much neutrons are producing? They are having high speed. So their speed want to reduce. For that they are using moderators. Moderators are heavy water as well as graphite rods. Now other thing, controllers are there. Controllers means here number of neutrons keep on producing continuously. So their number need to reduce. For that, here they are using controllers. Controllers' function is absorbing the excess quantity of neutrons production. They absorb. As in when more and more neutrons produce, these controllers will absorb the excess of neutrons. Now, which are the controllers? They are the rods of cadmium, then rods of boron and rods of beryllium. As a result of these moderators as well as controllers, there will be the controlled chain reaction inside the nuclear reactor. As a result of it, there will be some limitation, or we can say that some control will be in the production of energy. How much energy is producing, that energy utilizing for the production of electricity. So the energy which is producing, that is in the form of heat energy. That heat energy helping for the formation of steam. The steam which is producing, that is helping for the rotation of the turbines. As and when the turbines start to rotate, there will be the movement of the generator. Once generator starts to move, there will be the production of electricity. Thank you.